All right. So what is this bootstrap procedure? So in practice, we do not have access to the true population, right? So we don't even know what the true distribution is. So, and we are not able to generate a lot of different samples from the true population. So instead, what we do, we generate samples from just our only available sample, which is all our data set, but we do it with replacement. So it's something like this. So this is our data set. Then we just generate a new sample that has the same number of observations, but some of them are duplicated and some of them do not appear there. So it's like, I don't know. So maybe this one is going to be duplicated. This one is going to appear 3 times. This is not going to appear. This is not going to appear. So here is how it works. So here is an example. So if this is our data set, so the only available sample of size 10. So the bootstrap samples are obtained from just this only available sample as follows. So here are just 3 random examples. In the first example, so this is bootstrap sample 1, this is sample 2, this is sample 3. So if you look at sample 1, you will notice that, say, observation 5 here appears twice. Observation 6 appears twice. But observation 3 just does not appear. And in the second sample, observation 1 appears twice. Observation 3 does not appear again. So observation 3 actually did not appear in any one of them. So it was just unlucky. So it was not included into any one of these, just because of random chance. So this is how it works. Now, what I did, I tried to repeat the numerical experiment from the textbook, just to see if it works and how it works. So with the same parameter values. So I generated x and y to have mean 1, the same mean, and to have the following. So the variance of x is 1, variance of y is 1.25, and the covariance is 0.5, right? So now you can check by the formula that the true optimal value of alpha is 0.6. Right? So this is according to the formula from the previous part of the lecture, from part 7. And then I just plotted these simulated data sets as scatter plots, and you see in each one of them there is a positive correlation. So there is a positive trend for y in terms of x. This is because the covariance is positive. But at the same time, the estimated alpha is sometimes underestimated, sometimes it is overestimated. Of course, because it's just a bit random. Now, what I'm going to do now, I'm going to try 2 approaches. So here is the true population, right? So since I know how the data was generated, it is simulated data, I can generate 1,000 independent samples, right? So in my case, the number of samples is 1,000, and the number of observations, the number of observations in each sample, n, is 100. And this is my first approach. So this is my first approach. And every time I calculate the estimated alpha hat. Okay, so my second approach is I just take just one sample. So here I just take one sample. Again, so this is just the first of the samples that I used in the true population, right? So it's just the same one with 100 observations, and I did it 1,000 times. Also 1,000 times, just because so that the 2 histograms could be compared directly. So the number of observations of alpha hat here and alpha hat here, say star, just to distinguish. So alpha hat comes from the true population, alpha hat star comes from the bootstrap population. So the number of observations of this alpha hat or alpha hat star is the same. All right. So and you see the two histograms. So both are histograms of this alpha hat, and they are pretty similar to each other, right? So I mean, they surely they're not exactly the same, but the general pattern is similar, right? The third plot is the box plot, right? So in this box plot, what you see here is this is the median, bootstrapped or true. So these are outliers. So this is the third quartile. This is the first quartile. They I mean, they're surely different, but they're not too much different. And also, you know, we see how much it varies, and we see that the bootstrap estimate for alpha hat, it varies smaller. Its variance is probably smaller, but it's not really too big of a difference. Now, the mean alpha hat estimated from the true sampling is 0.6. This is because I rounded it to two decimal places. So the actual was something like 0.02 or something. I don't remember. Right. So the average estimate from the bootstrap sampling is an underestimate. Is slightly lower. So they are a bit different. Now, so standard deviation of estimates obtained by sampling the true population. Well, you know, this is from basic probability course, how we can estimate the standard deviation. Well, to be honest, this is not the. So this is square root of the variance. So standard error is square root of the variance. So this is, to be honest, this is a biased estimate for the standard error, but in any case, this is the usual, the one that is usually widely used in practice. So this is just standard, the square root of the variance. So in our example, we have, so I did it, I obtained 0.081, and this is more or less the same as in the textbook. In the textbook is 0.083 from ISLR. Of course, because, you know, they did it randomly too, and their random numbers were different. Now, the standard error of the bootstrap sample, basically, again, same thing. So I generated 1,000 bootstrap samples from just one original sample, and then just calculated their standard error, basically by the same formula, because this plays the role of alpha bar. So it's essentially the same thing. So which is why it is the same formula essentially, right? So my result is 0.07, which is slightly off. So it is a slight underestimate. In the introduction to statistical learning, so their numbers were a bit closer. So they got 0.63 here and 0.087 here. So in their case, the bootstrap estimate was an overestimate. In my case, it is underestimate. But in either case, it's not too far from the real number, from the actual number. And notice that the actual number is also random, right? Because we do not really know the true the true standard error, or the true standard the true variance of alpha hat. So it's not, I don't think that it's even possible to theoretically devise it. So it's just that the formula is too complicated. So that's it for the last part and for the whole lecture. So please do this little quiz about Bootstrap.